Hello there, this is Alana Tucky, and I'm going to be lecturing here on section 7.3 of Math 131, which is where we review a basic skill of algebra, beginning algebra, which is how to simplify square roots. All right, so let's begin with just trying to find some square roots of positive numbers. Let's work there. So we know that some numbers can look different but have the same value. For example, 1.5, we all learn in school, is the same thing as 3 halves, right? Or 1.5 if you like. 4/6 we all learn is the same thing as 2/3, right? Negative 10 over 2, that would be the same thing as, it doesn't have to always be a fraction here, it's negative 5. Same thing, right? It looks different, but it's the same. 35% means per 100, cent meaning 100 in Latin. So if you have 35%, you have 35 over 100. Or we also learned you can make that a decimal, 0.35, because 5 is in the hundredths place. It's all coming back to you now, right, from basic math. Somewhere along the line, you've learned all of this stuff. All right, so now that's also true for square roots. There are many kinds of roots, but the most common that we use in algebra class, especially beginning and intermediate algebra, would be square roots. So that's when you want to find a number that is multiplied by itself to make 45. Now 45 is not going to work out nicely, so we're going to use our calculator. And I'm going to find the square root of 45 with my calculator and 3 square root of 5 with my calculator. So let me pull up my calculator. There it is. It even has the last parabola we graphed. Okay, so let's quit. I'm going to find, clear, the square root of 45. And then I want 3 square root 5. They're the same thing. They're both 6.708. So let me put that in. All right, so now, is that something magical I did, or would it work out with other problems? So let's try it over here. I want the square root of 3/8. So that's square root 3 divided by 8. And I love this new operating system because you can tell that the 3 divided by 8 is inside that square root. Or you could have the square root of 6 and 4. So the square root of 6. And then you want to move your arrow key because division by 4 is not under that square root. Look back here. The over 4 part's not under the big square root, so you want to divide by 4. And hey, they're the same thing. They're both 0.612 and some change. Oops, come back. There we go. All right. So we've learned a valuable lesson here, which is that we're going to be able to take square roots, just like we did with fractions and decimals and percents, and change them around to different things that will look different, but they are the same value. So square root of 3/8 and the square root of 6 divided by 4 look extremely different, but they actually have the same value. All right, this is going to be a process that we're going to call simplifying. So we're going to be simplifying a square root. Now, what does it mean to be simplified? It means there will be no perfect square factors inside the square root. When you're done, no perfect squares will be left. Square factors, I should say. There are no fractions inside the square root. So that 3/8 business is no good to you. You're not allowed to leave a fraction under a square root like that. And there will be no square roots in your denominators. Okay? Now, before we get into all of this, we should probably remember to ourselves what the perfect squares are. So 1 squared is 1. 2 squared is 4. And so on. 3 squared is 9. 4 squared is 16, right? It's all coming back to you now. All right, 4 squared is 16. 5 squared is 25. 6 squared is 36. It's the diagonal of your times table, if you remember from back in the day when you were first learning your times tables in school. All right, so these numbers are the perfect squares. Now, there's more of them than just this, but these are the ones that we kind of know off the top of our head. At least hopefully we do. All right, so we're going to be looking for these to be factors. Factors means it multiplies. So you want to say, okay, does 4 multiplied by something else make the number? Like, for example, does 4 multiplied by something make 28? Yes, it does, right? But before we get into that, we need one more property, and that's the product property. The product property says that if you have the square root of a times b, that is equal to something. Hold on. There we have it. The square root of a times b is equal to the square root of a times the square root of b. In other words, you can take multiplication of square roots and break it up into two pieces. Now, you cannot do that for adding and subtracting. You can only do it for multiplying, and dividing is coming, right? So those are the ones you're allowed to do it for. All right, so let's practice the first thing. So the first thing says there are no perfect square factors inside the square root. So let's practice that. So let's start with the square root of 28. So the square root of 28 is equal to, now you need to look for a perfect square factor. So look back to this list. Which one of those numbers is a factor of 28? Well, rather obviously, it's 4, right? Okay, so this is the square root of 4 times 7. Now, according to the product property, that's the square root of 4 times the square root of 7. Okay, but the square root of 4, oopsie, is 2. So it's 2 square root of 7. And there you have your result. Done. Done your first simplification. All right, let's do it again for 80. Now we need to think. Now 80 is 8 and 10. So when I teach this in a face-to-face class, a lot of students will say 8 and 10, but 8 and 10 are not in this list. You're looking for a perfect square because you're trying to get rid of a piece of that square root, right? So 8 is not a perfect square, so it doesn't help you. 10 is not a perfect square, so it doesn't help you. So which of these numbers goes into 80? That's what you need to think about. So maybe you'll see 4. 4 goes into it. Okay, so let's do that. So this is, oops, I don't want to do it there. Sorry. Equals square root of 4 times 20. And then the square root of 4 times the square root of 20, that's 2 square root of 20. Oh, but you're not done, because 20 has a perfect square, namely 4, right? So I have to break down the 20 again to 4 times 5. And then I have to do it all over again. So the square root of 4 times 20 is the square root of 4 times the square root of 20. That's 2 times the square root of 20. Here, I'll do another step in here just for you. 20. And that's 2 square root 4 times 5. Okay, that's 2 square root 4 times the square root of 5. And that's 2 times 2 times the square root of 5, which is 4 square root of 5, right? What a mess. You can get there, but it's kind of ugly, right? And look how long it is. Gosh, it doesn't even fit in the screen. That's terrible. All right, so we're learning a valuable lesson here because there was another way to do this problem. So let me back up just a second. We could have taken 4, but there was another number in here that worked. And you can see what it must have been. There was a 4 there and another 4 there, which means 16 went in. Okay, so 16 goes in. So let me write that up. Hold on one sec. There we go. Okay, so let me try it again. So way number 2. Let me write it out. Square root of 80 is the square root of 16 times 5. That's the square root of 16 times the square root of 5. That's 4 square root of 5. All right, so we've learned a valuable lesson here, which is if you can, take the biggest way or the biggest perfect square you can. So let's make a note. Note. Take the biggest perfect square possible. Right? It'll help. Right? That was a lot less steps when we used 16 than when we used 4. Right? And here I'll highlight this just so you guys can see that it was a different method. Okay? So when we did 4 as our first number, it worked, but it was kind of ugly. So we're better off when we take 16 because 16 is bigger, and that means that I'm able to break it down faster. And I'm also going to be honest with you. As an intermediate algebra student, we stop writing this whole square root of 16 business. At some point, we kind of skip this step right here and go, okay, square root of 16, that's 4. That comes out because you're taking it, and the square root of 5 I leave under. And we kind of skip this step because we're going to be doing other problems, bigger things. Now, if you want to write that intermediate step, that's fine, but it's common to start dropping it after a while. So let's see, 75. 75 is 25 times 3. All right, so what I was just saying is the square root of 25 is 5, right? So you write 5 square root 3. and you're done. Now, if you want that intermediate step that often we skip in intermediate algebra, ironically enough, right? So it's the square root of 5 times the square root of 3. But this is your final result over here. All right, last one, 600. 600 is rather obviously 100 times 6. The square root of 100 is 10. And then so you have 10 square root of 6. And again, if you want that intermediate step, I just don't even think of it. It's the square root of 100 times the square root of 6. So again, it's not wrong, but in intermediate algebra and beyond, you start having to do so many other steps that that step becomes kind of by the way, ignoring kind of a thing. All right, so we're done with that bit. Let's see what's in the next bit. Okay, so fractions. So the quotient property says if you have the square root of AB, that is equal to the square root of A divided by the square root of B. Now, we only have these two properties for products and quotients. That's it. You do not have any for adding and subtracting. So notice, right, none of these problems have adding and subtracting. There's a reason for that. All right, so that means that there are no fractions inside the square root, right? You're not allowed to leave fractions in there. So let's do some basic ones here. So this is the square root equals the square root of 5 over the square root of 36. And that's the square root of 5 over 6, right? Because the square root of 36 is 6. And we're done with that one. Okay, what about the next one? Well, 64. 64 is a perfect square. So this is the square root of 10 over the square root of 64, which is the square root of 10 over 8. And you're done. Don't get into the mindset that you can start dividing 10 divided by 8. That's no good to you because this is under a square root and the 8 is not. They're not like terms, so you can't start dividing them. You just have to leave it like that. All right, now this one, 15 and 27, I want to break this down just a little bit here. So it was the square root of 15 over 27, right? Okay, now 15 is 5 times 3. So let me write that out. 3 times 5. And 27 is 3 times 9. Oops, not 89, 9. So the 3's are going to cancel. Not cancel, divide. That's what I mean. So they divide and leave you 5 over 9. So this is really the square root of 5 over 9. But that's really the square root of 5 over the square root of 9, which is really the square root of 5 over 3. And we're done. If I can get it to show up there. There we go. All right, well, we're done with this part. We'll come back here to talk about rationalizing the denominator. So that'll be the next video. I'll see you then.